Hey everyone, it's Kevin. Welcome back to the channel. In this video, I'm going to show you how to create these 4 easy plant pots in Blender for 3D printing. This is part of my Blender Basics for 3D Printing series, so if you haven't checked out that first video, I'll put a link below. There, I went over some tips to help you get started and finished off by making this custom keychain. It's a good place to start if you're completely new to Blender and looking to design things for 3D print. So here, I'll walk through the entire process of modeling these 4 pots step by step, how to optimize and slice it all the way to the final 3D print. By the way, I am using a Bambu Lab P1S and Bambu Studio as my slicer. Let's get started. Here I'm in a new Blender file, version 4.3.2, and I'm in the layout workspace. The first thing I'll want to do is delete these default objects, which is the light, camera, and cube, since we won't be needing these. Let's select them and hit X to delete. Next, we'll need to adjust our units to be compatible for 3D printing. Head over to the Scene Properties tab and under Units, make sure the unit system is set to metric and set the scale to 0.001. Then change length to millimeters, which is the standard unit most slicers use for 3D printing. Now, before we start designing, you'll want to decide if this is going to be a pot you'll plant directly into, or if it's going to be a cover pot. A cover pot just means the plant is already in another container, and this acts as a decorative outer shell. Both options can work, but for the pots I'm designing in this video, I'm going with the cover pot approach. Most of my plants, if not all, are in these clear nursery pots, so I can easily monitor how dry the substrate is before watering. If you do want to plant directly into the pot, no worries, I'll include tips for each design on how to modify it for that. Another thing to consider is measurements. Since I'm using clear nursery pots, when designing a cover pot for 3D printing, I usually just measure the top diameter and the height. If the bottom diameter is oddly shaped or flares out, I'll make note of it, but for the most part, those 2 measurements are all you really need. For each pot in this video, I'll be providing the exact measurements I used, but feel free to adjust them as needed. The first pot we'll create is this geometric one. Start by hitting Shift A and bring in a mesh cylinder. Now, you won't see it right away because it's huge, so we'll need to scale it down. Open the side panel with N and under Dimensions, click and drag from X to Z to highlight all 3 fields. Then type in 2.5 inches and Blender will automatically convert that to millimeters. You can also zoom out with your middle mouse wheel. Next, we'll need to adjust the geometry. Press Tab to go into edit mode, hit 3 for face select, or click the face select button up here. Let's remove the top face of the cylinder by selecting it and hitting X, then choose a delete face. Now we'll add some loop cuts along the side. Press Ctrl R and then use your middle mouse wheel to increase the number of cuts. If you don't have a middle mouse wheel, you can just click twice to confirm the cut, and then you'll see a small menu pop up in the bottom left corner of the viewport. Expand it and you can enter the number of cuts manually. I'm entering 9. Now I want to select all the side faces. To do that, with face select, select one face, then press Shift G to bring up Select Similar, and choose Area. That'll automatically select all the faces around the side of the pot. With them selected, I want to inset them to create our geometric extrusion. Hit I to inset, and you might need to press it twice to make sure it insets each face individually. Bring the inset in very small, almost imperceptible. You can hold down Shift to get more precise. Then scale it outward with S, then Shift Z to scale it out on the X and Y only. Next, hit M to merge and choose by distance. This will merge those inset faces into a single vertex. If it doesn't look like anything's happened, try increasing the merge distance slightly from the menu in the bottom left until they combine. Check that everything looks good and then go back into object mode. Now we'll need to give it thickness. Head over to the Modifiers tab, that's the wrench icon, and add a Solidify modifier. Modifiers are non-destructive ways to edit our meshes, and I like adding thickness this way because it gives us more control and keeps things clean. Generally, for 3D printing, it's recommended to have a minimum wall thickness of about 1 millimeter. When you enter that in, it might not look like anything happened, and that's because the scale of it is off, the scale of the object. So Blender is technically reading the object's old dimensions from when we first brought it in. So to fix that, make sure the object is selected and press Ctrl A and apply the scale to reset these values to 1. And let's toggle even thickness to make sure it's consistent throughout. Now the thickness should display properly. By default, the thickness is added inward, and depending on your measurements, that could tighten things more than you want. If you'd rather thicken it outward, you can flip the value to a negative instead. Just keep in mind that some of the outer geometry may warp slightly depending on your shape. Now, when printing something detailed like this, you can get away with 1 millimeter thickness, but if you want it to feel sturdier, especially if it's a larger pot, I'd recommend going with about 2 to 3 millimeters. Once you're done, apply the modifier by hovering over it and hitting Ctrl A. So now is a good time to do some last minute checks. Make sure all of your normals are facing outward, and you can turn on face orientation in the Viewport Overlays tab, and everything should show up blue. If you're using the most recent version of Blender, you might not see the blue, but if anything is red, hop into edit mode, select everything with A, and press Shift N to recalculate normals. Toggle off the overlay when you're finished. And finally, just double check that all modifiers are applied and that your object doesn't have any hidden geometry before exporting for print. To export this, go to File, Export, STL, and then you can bring it into your slicer software, which in my case is Bambu Studio. Now, I'm going to go over the slicer settings I use to print these cover pots, but of course feel free to adjust based on your own setup or preferences. So here I'm in Bambu Studio with the default preset selected. To bring in our file, go up to Add, then select your STL from the list. If we slice it as is, the estimated print time is around 4 hours, but we can definitely optimize that and bring the time down depending on the settings we choose. Jumping over to the Strength tab under Walls, I'm using 2 wall loops for these pots since they're just decorative cover pots. If you want it to feel a bit sturdier or you're printing something for direct planting, you can bump that up to 3 loops. Next is Sparse Infill. I'm using 10% gyroid infill here. These pots are hollow, so they don't really need much internal structure, but I still like having a little support inside just to keep things strong. You could drop this down to 5% or change the pattern to grid if you want to slice and print faster. Going to quality under layer height, I like to use anywhere between 0.16 to 0.2 millimeters, as it gives a nice balance between print quality and speed. If you're in a rush or printing a larger batch of pots, you can also bump it up to 0.28 millimeters to cut down on print time. Now, when we slice it, you'll see it cuts our printing time by almost half. Make sure you save this preset for the next pots in this video. Now, if you're planning on planting directly into the pot, you can use PLA, which is what I used here. PLA is non-toxic to plants, so it's totally fine for indoor use. And while PLA is biodegradable, that usually only applies to really industrial conditions, so it's not going to break down on your shelf or desk anytime soon. So for indoor use, it's generally safe. However, PLA isn't waterproof, and over time, it can degrade if it stays wet or is kept in a humid environment. If you're worried about that, one option is to seal the inside with a food-safe epoxy or waterproofing resin. Or if you want something more durable right out of the printer, you could use PETG filament, which is better suited for direct planting and even outdoor use. The other thing to consider is wall thickness. So for the pots that'll be holding moisture, I'd recommend going a little thicker, something like 3 millimeters for extra durability. And lastly, drainage holes. I strongly recommend adding them so you don't accidentally overwater your plant. So to add them, using our first pot as an example, just bring in a mesh cylinder and scale it down. I'll set the X and Y to 0.25 inches, and then I'll stretch it up in the Z so it cuts through the bottom of the pot. Now select your pot, go to the Modifiers tab, and add a Boolean modifier. Set the operation to difference, and then use the eyedropper to select the small cylinder. Once you've done that, apply the modifier, delete the cylinder, and now you've got a drainage hole in the bottom. You can definitely add more if needed, but that's the basic idea. Now, the second pot is the rounder, more organic looking one. Start by hitting Shift A and bring in a new mesh cylinder. And I'll set it to 3.5 inches in the X, Y, and Z. Just like before, we'll remove the top face of the cylinder by going into edit mode, hitting 3 for face select, selecting the top and pressing X to delete it. Now tab back into object mode, press Ctrl A and apply the scale. This again makes sure any modifiers we add behave properly. Let's add a solidify modifier from the modifiers tab. I'm going to set the thickness to 1 mm. Toggle even thickness and apply the modifier once it looks good. Now add a subdivision surface modifier with levels 2, which gives our pot more smoothness. And a shortcut for this is Ctrl 2. Go back into edit mode and let's remove the bottom face of the pot, both on the outer and inner sides so it's open. Although this modifier helps smooth everything, we've lost some of the definition, so we'll need to bring some of that back with cuts. Add a loop cut with Ctrl R all the way around the top outer edge and slide it up. Add another loop cut for the inner edge, again sliding it up, and add 2 on the top opening, one for the inner side and another for the outer to tighten those areas. Next, make 5 loop cuts going horizontally around the body of the pot. These will help us create that nice wavy structure. Now with edge select, Alt-Shift click every other edge loop. Then scale them out by hitting S then Shift C to restrict the scaling to the X and Y axes only. Once scaled, hit Ctrl B to bevel those edges and smooth them out. Use your middle mouse wheel to increase the segments and round them as needed. Once you're happy with it, go back into object mode and apply the subdivision surface modifier. Go back into edit mode and with edge select active, hold Alt and click the inner bottom edge loop to select the ring. Press F to fill it, and then repeat the same step for the outer bottom ring to fully close off the base. Now, you could leave the shape as is, but if you want to give it that melted organic feel like in the example, switch over to vertex select mode by pressing 1 or clicking this button here. Pick a point along the top edge of the pot. Then toggle proportional editing by clicking the circle icon at the top or by pressing O. This allows you to move a vertex and its surrounding vertices along a natural fall off, kind of like sculpting. It's really useful for creating smooth organic deformations. Now with G then Z, drag that point downward to gently distort the shape. Use your middle mouse wheel to adjust the area of influence. This controls how much the surrounding mesh moves with it until it looks just right. Once you're happy with the design, go ahead and do your final checks. Make sure your modifiers are applied and double check your face orientation under viewport overlays. Again, if you see any red faces, select everything in edit mode and hit Shift N to recalculate normals. Then go to File, Export, STL, and you're ready to bring it into Bambu Studio for slicing. Now, the next one is this elevated rib pot. Start by bringing in another mesh cylinder, and this time, let's set the vertices to 128 for the menu that appears in the bottom left corner. Set the X and Y dimensions to 3.5 inches and the Z to 3 inches. Like before, go into edit mode, remove the top face of the cylinder, and then add a loop cut towards the bottom of the mesh. Loop select the bottom edges and with proportional editing toggled off, scale them in slightly. Then extrude it downward along the Z to create that raised platform underneath. Now tab back into object mode and hit Ctrl A to apply scale. Next, go to the modifiers tab and add a solidify modifier. For this one, I'm setting the thickness to 3 mm and turning on even thickness. Once it looks good, go ahead and apply the modifier. Now let's create the rib texture along the sides. Back in edit mode, add a loop cut at the top and another at the bottom of the main body. This will define our margin area. Then select any of the vertical side faces, press Shift G and choose area to select all the vertical faces around the pot. With those selected, go to Select, check or deselect, and in the menu at the bottom left, enter 110 to deselect every other face evenly around the side. Next, right-click and choose Extrude Faces along normals. I recommend switching to top view with numpad 7 and turning on X-ray mode with Alt-Z or this button here so you can better see the extrusion depth. Extrude those faces inward until they go about halfway into the wall thickness. Then hit SZ to slightly scale them down along the Z axis. This helps avoid any potential overhangs and keeps the ribbing clean. Once you're done, you'll have a nice elevated ribbed pot. Again, be sure to do your last minute checks, recalculate normals if needed, apply all modifiers, and double check your face orientation to make sure everything is print ready. Then go to File, Export, STL, and you're good to bring it into your slicer. Now, the last pot is this happy face pot. Start by bringing in a mesh cylinder, and this time I'll set the vertices to 64. In the side panel, set the X, Y, and Z dimensions to 2.5 inches. Go into edit mode, remove the top face, and switch to vertex select. Turn on X-ray mode with Alt-Z. Now, box select the bottom vertices and scale them in slightly to your liking. You can leave it as a straight cylinder, but I want to taper the shape just a bit to resemble a small cup. Once you're done, turn off X-ray, then add a loop cut near the top of the mesh to define the lip of the pot. Now, back in object mode, apply the scale with Ctrl A, and then go to the modifiers tab and add a solidify modifier. I'm setting the thickness to 3 mm, toggling on even thickness and applying the modifier once it looks good. Back in edit mode, switch to face select, loop select the top ring of faces that make up the lip, and hit E to extrude, then S, Shift Z to scale them outward while locking the Z axis. Now switch to edge select, loop select the inner edges that connect the lip to the rest of the body, and hit G twice to slide them downward along the mesh. This helps reduce potential overhangs and gives us a smoother transition. Once you're happy with it, go into object mode and hit Ctrl 2 to add a subdivision surface modifier with levels 2. Like before, go back into edit mode, remove the bottom faces of both the inner and outer sides, and add loop cuts to bring back definition along the top and the body. If the top of your pot is looking a little uneven, hop into front view, toggle X-ray, and with vertex select, grab those top vertices and flatten them out by pressing SZ0. When you're finished, go into object mode and apply the subdivision surface modifier. Then in edit mode, loop select the inner bottom ring and hit F to fill it. Repeat this for the outer bottom ring to fully cap the base. And now we have the base pot. Next up is the face. Let's start with the eyes. Bring in a UV sphere, set the dimensions to 0.3 inches in the X, Y, and Z, and move it to the left side of the pot. You want it positioned so that it's wedged about 1/4 to halfway into the pot's wall. It doesn't need to be perfectly flush. It's actually okay to have a slight tilt because it avoids those harsh overhangs. Use X-ray and different views to position it cleanly. Once it's placed, add a mirror modifier, set the pot as the mirror object, and now you've got a matching eye on the other side. When you're satisfied, go ahead and apply the modifier. For the mouth, bring in a mesh circle, but set the X and Y to 0.5 inches. Rotate it with RX90 and bring it to the front of the pot. In edit mode, with vertex select, delete the top half of the vertices to give us half a circle. This will be our smile. Go back into object mode, right click and convert it to a curve, then apply the scale. Head over to the Object Data Properties tab and under Geometry, Bevel, set the depth to around 2.5 mm to give it thickness. Now select the top 2 vertices and extrude them up slightly, lock to the Z direction to help it sit properly. When that's done, go into object mode and convert it back to a mesh, then add a subdivision surface modifier to smooth it out. Back in edit mode, loop select the edges just under the smile's top edges and hit X to dissolve them. Then shift loop select the top edges and press F to fill in those faces. To smooth them out, bevel them with Ctrl B, adjusting the segments with the middle mouse wheel. In object mode, position the smile into the pot, about 1/4 to halfway into the body, and rotate it slightly downward to fit better. When you're happy with the placement, shift select the eyes and mouth and hit Ctrl J to join them into one object. The subdivision surface modifier will now affect the eyes, but that's okay as it'll add a bit more detail. Once it looks good, apply the modifier. Now select the main pot and add a Boolean modifier set to difference. Use the eyedropper to select the face object and then apply the modifier. Hide or delete the eyes and mouth object, and you should see the face features clearly inset into the pot. If you want to vary the height of the pot lip or give it a more playful look, you can use proportional editing to raise or lower parts of the lip like we did earlier. Once you're happy with the final shape, do the last minute checks, recalculate normals, apply all modifiers, and verify your face orientation. Then export as an STL and bring it into your slicer. And that's it for the pot tutorial. Thank you so much for watching. I really appreciate it. If you have any questions or comments, feel free to leave them below. Also, if you haven't checked out the first Blender Basics video for 3D printing, I'll link that as well. Thanks again, and I'll see you all in the next video.